Hey everyone, it's Lwandile here, the leader and the instructor of Manekwe School. And today we're gonna be jumping on to the whole new chapter, which is entitled Selections. We're basically going to play around with if-else statements, switch statements, and other things too. So of course, what's gonna determine is the exercises themselves. It's going to depend on what exercising we do, or on what exercise we actually do. That should be it. Without any waste of time, let's just get on to the question itself. Oh, by the way, I was actually I just woke up. I was taking a nap, so I just woke up. I don't know if my voice can be heard properly, but I hope so. So without any waste of time, let's just jump onto it. Okay, to start with, I will simply read the question through and then later on go to the solution. So it's an algebra problem. We're basically solving quadratic equations. Okay, so the two roots of a quadratic equation, ax squared plus bx plus c is equals to 0, can be obtained using the following formula. Okay, they told us that. As you guys can see, I don't have to say it out loud what's going on here. I don't have to say a thing. Everyone can see that r is equal to minus b. R is equals to minus b plus square root of b squared minus 4ac all over 2a, and r2 is equals to minus b minus square root of b squared minus 4ac all over 2a. b squared minus 4ac is called a discriminant of the quadratic equation. If it is positive, the equation has two real roots. If it is 0, the equation has one root. If it is negative, the equation has no roots. Okay, so we gotta write a program that prompts the user to enter values for a, b, and c and displays the results based on the discriminant. Okay, if the discriminant is positive, display two roots. If the discriminant is 0, display one root. Otherwise, display the equation has no roots. Note that you can use math.pow x and user 0.5 to compute square root of x. Okay, here are sample runs, and as you guys can see. Oh, before I even in fact, what I should have done is to show you guys the textbook we're using in case you're watching this for the very first time. This is the textbook here. You can search it anywhere online, and so that you can have your own copy. Otherwise, I don't want to lie to you guys, you will be wasting your time. Why? Because the grass look greener on the other side of the fence. In simple terms, some things, they always look simple and straightforward in your eye, only to find that if you actually think about the details, or when you think about what it took in order to reach that level, that's where you get to realize that it is quite a difficult thing to do. Okay, so right now, again, I will go back to the question itself. Oh, another thing, in case you're curious, why am I using the latest edition? It's simple. Why am I not using the latest edition? It's simple and straightforward. I don't want people out there to copy and paste my solution. So what I want you to do is to have your own copy of this PDF and then try to attempt these exercises beforehand, and then afterwards you come and check your solution, or rather compare your solution to my solutions. Okay, so that should be it. Let me stop with the talking and try to actually do the coding itself. I've already read the question and I'm not gonna do that again. In case you have to, you can pause this video and then start over with the question. Okay, so right now what I want to do is to simply create a project. I'll simply name that project exercise. 3.1. This is our naming convention. What we do is we call our projects the name of the class, the name of the exercise we're about to do. So where's my folder? Oh, this is it right here. I'm so sorry for that, you guys. You see, I've got that's my niece annoying right now. So she's a bit annoying sometimes, and because I decided to take this video from home, of course this might have a negative impact on you guys. So sorry for that again. As you can see, she's literally crying right now, and there's nothing much I can do rather than continuing giving you guys the solution. Again, I'm not quite sure at the moment how many solutions I'm gonna have for this problem. So it's 3 underscore 3. I should go 1 and then A, which simply says we're doing this from student A's perspective. I promise you guys now there will no longer be any mumbling. We're no longer gonna have any words. It's time to code. It is time we talk the talk of Java programming right now. Again, what's the very first thing to do? The very first thing I will do will be to create a scanner. As you see, you guys, people, they passing by, they yelling and everything. But what matters the most is what you see on the screen. System.in. Can go system.in here. Everyone knows that. And another thing, you might hear people greeting me in my language, of course. So I hope, again, that's not gonna get on your way. What you wanna do is to simply focus on what's happening on the screen. That's all. Okay, we gotta create a scanner. What we then do, we declare. Again, I'm not bothering myself much about comments. Why we did a lot. We dealt a lot with comments on my previous chapter. In case you haven't watched it, please do so. Chapter 2 on that same exercise. Textbook. So declare variables to hold A, B, and C. Okay, we simply do that by going A, B, C. What you wanna do now, wanna prompt the user to enter why did I do enter A, B, and C. Okay, system.out.print. I'm trying to be as fast as I can now. I've been talking a lot. Okay, now we gotta go enter A, B, enter A, B, C. What we then do is to go A is equals to scanner.next. Everyone knows this part, how to read a value from a keyboard. So I'm assuming there's nothing much to explain on this, right? Once we do that, we gotta calculate our discriminant. Okay, I don't even know if I spelled that correctly, but even if I didn't, this is not an English class, okay, or tutorial rather. Discriminant, that's gonna be B times B minus 4 times A times C. That should be it. Again, as you guys can see, I hope you guys can see, we're no longer doing stupid things such as having bad names for your variables. We will always have descriptive names from now onwards. We're no longer forgetting comments, so from now onwards we'll be having code which is well commented, right? Okay, those were the kind of mistakes that student A did. So now he has improved. So I hope you did too. Okay, so discriminant, if discriminant is greater than 0, what is it we say, or rather do? We will we'll find 2 real roots. Okay, double first root is given as it's minus b plus math.pow, and here I'll put, of course I have to put discriminant there because I want the square roots of discriminant. Check this out, you guys. We were told here that math.pow x, and if you put 0.5 next to x, that's gonna give you a square root of x. Okay, what else we then do? We simply divide the whole thing by 2 multiplied by a. That should be it for the first value. So without any waste of time, let me simply copy and try to paste right over here. Instead of a plus, I'll put a minus, and I'll replace the word first with the word second. Again, copying and pasting logic code, I strongly don't recommend people do that. However, I'm doing it anyways. Why? I'm trying to avoid wasting too much time on this video here. We've already taken too much time, so what I want to do now is to give out the solution, right? Okay, what I'll simply say is the equation has 2 real roots. Okay, and then I'll simply put those roots right here, and they'll go, well, I need 6 numbers after a decimal place point. Okay, then I put a f, of course I have 2, and let me just go 5 numbers after a decimal point on this one. Oh, let me go to the next line so that everyone can see. Again, people might be making noise. They might be making noise as they pass by. So I'm hoping you guys can properly see what's going on the screen, because that's what matters the most. If you all ears, there's absolutely nothing you're going to miss, right? That was the first case though. So else, if we know that we've got 3 different cases, discriminant, and this is our second case. So in this case, we're only gonna have one solution. Again, what I can do is, I don't recommend people do this. What I can do is to simply go copy. I'll simply copy what we had in the first case, and I'll call this root. Why we're only having one discriminant. Did I misspell this word? Even if I did, it doesn't matter. Let me just copy and paste right there. Okay, so this is what we're gonna have. However, you guys got to know that since I'll be having more than one solution out of this exercise, it won't be a best solution, of course, because as you guys know, we've got 3 different students, so we're doing it from 3 different perspectives. So what I'll simply do again is go system.out.printf, and then I simply put the equation has one real root, and I put that right here. It's gonna be 2 point, let me just put a 4 numbers after a decimal point this time around. Why not? And I'll put a root here. Again, you guys, in case you've already pointed out what is a bit incorrect about this solution, please let me know down in the comments. That way I can assure you you will improve dramatically, right? Why? Drastically, that's what I wanted to say. Why? Because you will be actually interacting with me, because you might point out something only to find that thing that you've pointed out actually is a good thing to do, you see. But if you've pointed it out, you will you won't be the same as someone who did not point a thing out, because by pointing out and find that you're wrong, it will make you not do such a mistake next time, right? I don't know if people get me there, but anyways, let's continue. The equation has no roots. That should be it for this tutorial, folks. Again, I strongly recommend people comment out their code. So let's start over right at the top. What we did is we created a scanner. So this is a straightforward part. We declared 3 variables. As you guys can see, it's not like you always have to have the word variable for each, the word double for each and every one of your variables, especially if they have one and the same data type. You can simply have them declared in one line separated by commas. Okay, so what we then did is to take user input here and then store whatever the user decided to give us to each and every one of our variables. Okay, once we do that, we then calculate a discriminant based on those variables, and then lastly, that's where we will determine if our discriminant is greater than 0. We calculate our first and second roots, and then lastly we display those values. Okay, our second case, we check if our discriminant is equals to 0, and if it is, we know that we're only gonna be having one solution, one real root. We display that real root, and we'll be having 2 numbers after a decimal point. And then lastly, this is our last case where our discriminant is actually negative. So basically we'll be having a square root of a negative number which is undefined if you punch it on your calculator, right? Okay, let's try to hit the run button. I don't wanna talk much about the square root of a negative number, but if you do mathematics, or if you did mathematics, you would know that belongs to complex numbers. So I don't want to even talk a bit about what those are, right? So basically now let me take the exact values they decided to use here. So it's 1, 3 and 1. I'll try to put exactly that and see what we get. So we have these 2 values. Now you've got to check if they correspond with what they give us. It seems like the two numbers do correspond. Let's try the second one. Oops, what was that? I did not do that intentionally. Okay, let me start over and try to copy and paste. What I'm trying to do here, folks, I'm trying to show that my answer is indeed correct. So it's not like I'm giving you wrong answers, wrong solutions. I mean, all of my solutions, they do work. Of course, why did you have minus 1.00 and 4 zeros? It's simply because right here I decided to make my output have 4 numbers after a decimal point, and since this is a 1, those numbers will be zeros. With that, I mean that will be all. Of course, you can typecast. Of course, you can change this value here, but we don't have to do that because we still have got to check other cases too. See, if you put another number here, another number for A, B, and C. For example, let me try to put something else. However, I want B squared minus 4AC to be 0. Or it doesn't matter. You know what? Let me just not do that. Let me continue with the last case. You can play around with this any way you like. You will see it yourself, you guys. What I was trying to say. What I was trying to say is we don't have to change this in order to get that minus 1 instead of minus 1.00, this minus 1 here. Right? So that should be it for this tutorial, you guys. I'll see you on the next one, and please let me know what is it you think we did wrong on this exercise, and I'll try to get back to you guys. I'll also give another solution on the very same exercise just to improve my solution. Why can I pronounce that? Just to improve my solution here and there. Of course, it's not the best one you can possibly have. Perhaps you had a right solution yourself, so a better one compared to this one here. So please let me know down in the comments, and that should be it for this tutorial, you guys. I'll see you on the next exercise. Cheers, you guys. Tutorial. Cheers, you guys. I'm gone.